and 56, and next greater element 3. So for this problem, we are giving a positive integer n, and we're going to find the smallest integer which has exactly the same digits existing in the integer n and is greater in value than n. If no such positive integer exists, we're going to return -1. So this problem is similar to the problem on Leetcode 31, next permutation. Yeah, we just need to find the next greater element. So for example, this is 1, 2. So all the elements should have this 1 and 2, and it's going to be on 21. So for this one, this is 21, but we cannot find the next greater element for this 21, so we're going to return a -1. So first of all, this n is only 2 to the power of 31 minus 2 to the power of 31 minus 1. This means n going to be a small number, and basically the length of if we turn this n into a string, the length may be 9 or 10. So this means basically we can use brute force to solve the problem, because if we use permutation, maybe it is 9 times 9 factorial, so the time complexity is okay for this problem. So this is the brute force. So let's just check the brute force idea. So first of all, we're gonna turn the number into a string, and we prepare a result and the difference. So from the beginning, we set the difference to be infinity. This is just for checking. And now we have the permutations of all the numbers, right? And then we're gonna turn all the string into a number. So if this number is more than n, but we are not sure if it is the next greater element, so we're gonna have a check if num minus n less than the difference. So from the beginning, the difference is infinity. If it is okay, so we're gonna reduce the difference. So the difference is gonna be num minus n. Yeah. So if this num less than 2 to the power of 31 minus 1, we're gonna set the result. Yeah. So finally, we're gonna return the result. So this is because n is 2 to the power of 31 minus 1. This is why we have to check. Yeah. Otherwise, so for example, if we have a big number like 2 to 3, 1, 5, if it is exactly inside of the range, but what about the next greater element? If we turn it to 51, maybe it goes out of the range. So this is why we have to check from here. Yeah. Now let me just submit it to prove this idea also works. But this is just the brute force idea. We didn't use any tricks. Yeah, as you can see, it works, but it's really slow. It's like 4 seconds. Now we are going to talk about a better idea, so which is the next permutation idea. So for solving the next permutation, normally we're going to use an example, otherwise we might forget about it. So my example is like 1, 2, 3, 4, 3, 2, 1. So I'm going to use this one as an example to solve the problem, otherwise it's going to be too hard. So for example, I'm going to use 1, 2, 3, 4, 3, 2, 1. So what is the whole steps for solving the problem? So we're going to permutate or iterate from the right to the left. And we want to find a pivot element. So from the right to left, if we find an element, so for example, this is 4, which is greater than the previous element. So this is 3, 4 is more than 3. Now we're gonna check a pivot. So this index with 3 gonna set as my pivot because I'm gonna use it. Yeah. And the second step is I'm gonna loop through the array from the right to left again, and I'm gonna check the element which is greater than 3. So 4 is greater than 3, so this means I need a swap. So after swapping, I'm gonna have a 1, 2, 4, 3, and 3, 2, 1. But this is not the final answer. We need to reverse what left behind after the pivot. So after pivot 1, 2, 4, it is okay. After pivot, it is 3, 3, 2, 1. So we're gonna reverse 3, 3, 2, 1. It's gonna become 1, 2, 3, 3. So the final answer is gonna be 1, 2, 4, 1, 2, 3, 3. So this is the next greater element for this number 1, 2, 3, 4, 3, 2, 1. Yeah. So this is all the steps. So basically we have 3 steps. The first step is to find the pivot from the right to left, and the second step is the swap with the pivot, and the third step is reverse what left behind. So for this kind of problem, it's just like you need to remember some patterns to find the next greater element. So the best idea is just to try to find an example and then use the example to remind you what about all the steps for solving the problem. Now let's just use this kind of steps to solve the problem. So first of all, I'm gonna prepare a nums. I'm gonna prepare array, and inside I'm gonna turn it into string and list it. So this is gonna be an array, and inside it's gonna be character or string of the nums. The second step is that I'm gonna use this n. So my new n, I'm gonna use it as the length of the nums, and then I'm gonna set a pivot to be none from the beginning, and then I'm gonna loop through it from the right to the left. It's gonna be n minus 1 with 0 and with minus 1. Here I set it as 0 because I'm gonna use nums I with nums I minus 1. This is why I set it as 0. So I'm gonna have a tag if nums I more than nums I minus 1. So this is for if this 4 is more than 3. So what I'm gonna do, I'm gonna set the pivot. So currently I find the pivot, it's gonna be I minus 1 for this index, and I'm gonna break it immediately. Otherwise I gonna make a mistake because we are finding the next greater element. So this is gonna be the first step. So now we're gonna check the pivot. So if pivot equal to a none, so basically this means we didn't find it. We're gonna return a -1. Now if we didn't return a -1, this means we find the pivot. So we're gonna continue with our second step. So what is the second step? Second step is just the swap. So I'm gonna use the for loop again. So for I in range n minus 1, 0, and to -1, I'm gonna still use the same loop. Because definitely, for example, this is 1. If I find a pivot, it must not be this 1. It must not be index 0. So this is why I'm gonna still use the index 0. I'm gonna still use n minus 1 to 0. This means from n minus 1 to 1. To index 1. So I'm gonna directly swap it. So it's gonna be nums with pivot with nums I equal to nums I with nums pivot. But when I need to swap, I need to have a check. So if nums I is more than nums pivot, so this means I find the number. So this is 4. I find this number 4 is more than the pivot 3. So I need to swap. Now after swap, I don't need to swap any other numbers. I just need to swap once. So after swap it, I have to break it. Now I finished the second step. I'm gonna continue to the third step. So for the third step, I just need to update the reverse. So the reverse of nums with pivot plus 1. So I'm gonna reverse from pivot plus 1. So it's gonna be nums with pivot plus 1, but I need to reverse it. So I'm gonna give a -1. So this means reverse. So finally, I'm gonna return the result. I'm gonna turn this nums into an integer. So first of all, I'm gonna join the nums together, and then turn it into an integer. I'm gonna return it. So I will set it as a result. So I'm gonna return the result if the result is less than or equal to 2 to the power of 31 minus 1. Otherwise, I'm gonna return a -1. This means maybe the number is too big. I'm gonna return a -1. So this is all the process for this problem. I think it is a difficult problem, but if you've already solved Leetcode 31 next permutation, basically it's gonna be easier for you to solve. But you may forget about it, so the best idea is that why not just try to remember an example. Maybe you're gonna use this kind of example like 1, 2, 3, 4, 3, 2, 1 to remind you what is the whole process for solving the problem. Basically, it's gonna have 3 steps. Now let me just run it to check if it works. Now as you can see, it works, and we didn't make any mistakes because we just use this example to remind us all the steps for solving the problem. Now let me just submit it to prove it works. As you can see, now it works and it's really fast because currently the time complexity becomes nearly 01 because currently this nums, the length of the nums may be just 9 or 10, so the time complexity is going to become 01 nearly. Yeah. Thank you for watching. See you next time.